All right, thank you very much. Way to set expectations. Thank you, John, for that. Thank you for all coming to the keynote. As you can tell from the title, I love alliteration. But beyond the L's, I hope to convince you that there's some interesting relationships between all these things. And we'll start with liveness. Now, I'm not going to assume that everyone here is very familiar with live programming necessarily. At least I spoke to some people who weren't. And I don't know, just a show of hands would be interesting. How many people have used a live programming environment in production? Yeah, that's what I was afraid of. It's fine. That way, at least, I have perhaps interesting content. So what we see here is a Newspeak workspace. Newspeak is a programming language that I designed. It's an object capability language descended from Smalltalk. But if you don't know what any of that means, it doesn't matter, because that's not the topic of the talk. The topic is liveness, and Newspeak is also live. And so I'll be demoing that. So you can look at this, and you can sort of get an idea of what it does, right? Hopefully, everyone can see this. There's a button here that says Evaluate Selection. You can see there's some sort of text area with what looks to be an expression. And you can imagine you select this, you press that, and you get a result, and it looks like the result prints out here, right? So it's sort of a REPL. It's really a REPL on steroids. There are lots of advantages to the sort of Smalltalk workspace format. But the problem here is exactly that you can kind of see what it's doing, right? You can imagine it. You can simulate this in your head. And we have computers, so you don't have to do that. But this is a screenshot. That's what you typically get inside slideware, right? You get a dead workspace, to paraphrase Monty Python's Parrot sketch, right? It is no longer with us. It has ceased to be. And so let us rid ourselves of this stinking corpse and try and get ourselves something a little more alive. So now we have a real workspace. So now we can verify what we thought it does. Right? So we can type, and we can select it, and we can evaluate it. And yeah, it might be interesting. Does it have keyboard shortcuts? Let's find out. Yes, it does. And now we learned something we didn't know before, that all the results are listed down there. And as we hover over this, we see it responds. So in fact, this is another thing we couldn't derive from the screenshot, right? Which is, this is a link. And now we have another one of these evaluator thingies. They're called object presenters, and we'll see quite a few of them in the talk. And this one is an object presenter on the object 7. Right? And so it lets me evaluate things as well, but it lets me evaluate them in the scope of this particular object. So if I say self times 6, and I evaluate that, I get 42, which is what we always wanted. And this is known technically as liveness level 2. There's a hierarchy of descriptions of live programming systems that is due to Steve Tanimoto, who's a professor at University of Washington. And he wrote this paper decades ago, but it's been refined and modernized over time. But basically, liveness level 2 means that you can evaluate things and get a response, right? There's somebody home, right? And so that's the basic thing, and that's what you typically see in REPLs and things like that, right? But maybe we want more. So, well, am I clicking in the right place? Yes. Now I clicked on that button, and now we've switched to with live evaluation. And hello, where am I? That's right. So now you see it says live. Live is the name of the workspace. If there's nothing there, it evaluates the self. But if I type 3, right, it's basically now it's evaluating every keystroke. So I type plus, it tells me there's a parse error. If I press 4, we got 7 again. And this is known as liveness level 3. This is where you don't have to ask. Right? It evaluates all the time, every time. And so for evaluating 3 plus 4, most of you have been to grade school and don't actually need much help with that. But when it gets to be more complicated pieces of program, then this has an advantage. And the advantage is that we've shortened the feedback loop. So apart from the fact that liveness gives you the ability to not have to simulate everything in your head, the other thing it tends to give you is shorter feedback loops. And the shorter the feedback loop, generally speaking, the better, for several reasons. One, the obvious one, it saves time. The faster you can do this, the more iterations you can get into some given time, and the faster you can make progress. But that's maybe not the most important thing. The most important thing is that it preserves context. Both the context that you're in, you can see where you are, and you remember your short-term memory. If you keep this fast enough, you don't have to remember what was I doing before I went off and do a build or some other distraction, right? So that's some aspects of liveness. Now, before I move on, I want to mention a couple of other symptoms of liveness that we've seen here that aren't related to these evaluators themselves. But the first is, right, we have a live evaluator in our slide. This is something I can't do in PowerPoint, in Keynote, in Google Slides, in whatever, right? This is sort of why I'm forced to use my own slideware. But that is one thing, because now I can actually, I don't have to switch context to do the demo. The other thing, of course, is, remember, we started with a screenshot, and we edited the slide to put this in, right? We edited the slide while I'm presenting. Again, it's modeless. I didn't go into some mode where I edit the slides. Heaven forbid I did not go to some markdown and start writing stuff there in an editor, right? I mean, there are great advantages, don't get me wrong. I've written about the advantages and disadvantages of these things, and this system tries to bring them together, by the way, because the source for this is HTML that you can edit live. But again, that's another talk. But the point is, liveness in general is a good thing. Liveness is cool, right? Is basically the message here. So before we go further, I think it's worthwhile looking at the history a bit of how we got here, at least one particular view of how we got here. And I'm going to go back to 1837 with the invention of the telegraph. And you may have seen these devices in old movies or movies about the 19th century, basically. There's usually a postmaster in a Western, and he clicks on this thing, level K, and he puts out Morse code, right? So that's the first long-distance electronic communication. Now, fast forward 30 years, and you get to typewriters. Now, there may be people here who have never seen a typewriter in real life, I suspect. But in any case, something will be familiar to you. Look down here. You recognize those horrible letters, QWERTY? Right? This is where that disease comes from, right? And the reason for that disease, if you can see up here, each key press is actually connected to so one piece of metal that eventually moves the keys that have the type printed on them, that slam into the paper and leave an imprint. And they're in a sort of semicircle, and they all, when you press them, they all move to hit the middle. And if you have keys that are too close together and you type fast, they're going to jam. So you want the letters that follow each other to be far away from each other. And we have this now on my Macintosh because some reason, right? We don't know why. But these things live on forever. There was a reason once. There's a bunch more of things that we've inherited from the typewriter. But let's keep moving along. And again, about a generation later, people decided, let's put typewriters and telegraphs together. So now I can type on one end, and it'll, the typewriter on the other end of the line will type. So basically, use a typewriter as a remote proxy for another typewriter. And this is called a teletype. And people started working on this in the 1900s or so, and it really caught on in the 1920s. And again, another generation or so, we get to having computers, and some bright-eyed young engineer has this brilliant idea. Let's hook up a teletype to a computer. And this is a teletype that hooks up to a computer. It seems to me to be exactly the one that I got to work out in 1975 when I was in high school. I don't know if this is an advantage of being old, but I did live with these machines. And I was very fortunate because on one hand here was me, and on the other side of this thing was a BASIC interpreter with a REPL. A REPL, incidentally, that's a lot better than most REPLs you use today because BASIC was designed to use the REPL. And you can see, and the way it worked, right, you'd type in your BASIC command or expression or whatever, and then you'd hit return, and then it would type the answer back at you, right, on paper. Right? And you can see why you need this line discipline, because you can't have the liveness level 3 where every keystroke starts to provoke a response so you see what you're doing, because it'll be a jumble of characters between what you're typing and what it's typing, and every time, and if the response is long, it'll take it too long, and all these things, right? So you want this half duplex. You type a line, please let me know that you're done, then I'll type up a line, right? And we still have this in our REPLs today for the same excellent reasons that we have QWERTY. So the thing about this is that we don't have to, but we're stuck with all kinds of legacies from these devices, and lines are everywhere. Lines are in our error messages and in our debugger information, and all kinds of places where people are obsessed with lines, which they shouldn't be. Another thing, I'll make this bigger. So you can see here, maybe you can make it out. Line feed and carry and return, they're separate keys. And the reason is because those are separate operations. You have to turn the paper, right, so that you move to the next line. And then the print head, which you can't see here, has to move to the beginning of the line, and those are two separate things. And in fact, it's even better with our old friend, the typewriter, because here, again, yes, you roll it, and here there's no print head, so really the paper has to move. Every time you print a character, it has to move a little to the left so you won't keep printing in the same place, because all these keys go to the center of this arc. And so at the end of the line, you just take the carriage that it sits on, that's why it's called carriage return, and move it back to the beginning. And so when they started designing teletypes, they turned them into codes that they could send over the telegraph line. And those codes lived on and got put into ASCII, and we still, and if you've ever had to take a text file from one operating system to another and found this jumble of control M's and control J's because one of them thinks that a new line is carriage return line field and the other thing is just line feed or whatever, it's all because of typewriters. Now, if this kind of perverse history interests you, then this is my blog, and there's a post that's fairly recent that discusses REPLs and why they're not the perfect solution, because just too many people think that, oh, if I've got a REPL, I've got interactivity in my programming language, and yeah, in some, at level 2, kind of you have, but you can do so much better. So anyway, I don't have time, when I'm trying to get this into 45 minutes or so, so I'm not going to go into the details, but this tells you the story starting with the teletypes, moving on from there through various things, and if you like these curiosities, give it a whirl. Now, I'm ragging on REPLs, but I do want, it can always be worse. That's a good philosophy of life. And here, this machine, there's a keyboard again, but it isn't even connected to a computer. This machine types punch cards, right? You can see a card in here and a card there. And, well into the 70s, this is how people wrote their programs. Now, in some cases, because they were highly paid software engineers, they were not forced to actually type on these machines. No, they lived the lifestyles of the rich and famous. They did this. They filled out coding forms. So this is an IBM Fortran coding form, and it has columns, and you write your program, you write it, preferably in pencil, because you'll have to correct it probably along the way, and then you hand it to the typist pool, and they'll use the other machine. And at the end of this process, you have a stack of cards, right? And you take this stack of cards to the operator of the mainframe. One does not approach a mainframe directly. One has to go to the priest. And you hand it over, and they tell you to come back in 3 days. And when you come back in 3 days, he gives you the printout of what your program did. And if you aren't very careful, it might say something like, syntax error, missing semicolon on line 15. And then you go back, right? Which means that you had better be damn careful, which means that you have to simulate the parser in your head because you can't afford syntax errors because they'll cost you days of waiting, right? And this is, again, the point about the feedback loop, that we want feedback loops to be short and get immediate results, and this is an example of a very dead situation where the feedback is very long. And technically, this is liveness level 1, by the way, which means dead. And if you know the Monty Python sketch, you can imagine the pet shop owner telling John Cleese, oh, the parrot, it's not dead, it's just liveness level 1, right? So, leave something to be desired. And again, if you like history, check my YouTube channel. This is a talk from a few years ago that's a different slice through history. This will take you from this gadget that you can barely see in the picture, which is, I believe, the first programmable loom that at least is preserved in some museum in France from the 1720s. And it'll take you through Fortran, through APL to functional programming. So if you like it, good. And if you don't like it, you're obviously in the wrong talk. So of course, there's liveness, serious liveness doesn't end with level 3. In fact, level 3 is not where we want to be. Level 4 is where it gets interesting. This is what you get in Smalltalk or Self or the Lisp machines, right? Done right. Liveness level 4 is defined that you can change your program while it's running in arbitrary ways with immediate effect. So we'll demonstrate this in a minute, at least demonstrate some of it, but we can't demonstrate in the time I have the more impressive aspects. But here, again, another object in presenter. This one's on a list, and therefore I can evaluate in the scope of the list. So the list is empty right now, but if I evaluate this, right, it's 3, and this shows me the list, right, at index 1, there's a 3. And since I don't want to keep selecting this, I'll make it into a button. And then I can keep adding things, right? But this is, the reason I'm doing this is A, because it's a demo I've been giving for 30 years and I love it and whatever, but also because I want to have some state here in this thing when I do the actual level 4 thing. So there's a menu here, and there's an option called Inspect Presenter, and that takes you to another object presenter, but this is an object presenter on an object presenter. It is inspecting the object that is the GUI object that was presenting the list that we just saw. And the nice thing about these object presenters is that I can open, you see the source code, I can open this and I get an embedded class browser, and you don't have to know Newspeak or anything. We're just going to go to some suitable code. We can open a method here, and I don't know if you can see that, but most of you can't read it even if you could see it. But basically, there's a thing here called caption color. It's setting the color of something, and I'm going to change that to say color green. And then I'm going to accept it. So this is liveness level 2, by the way, because I don't actually want, as I'm editing my method, everything to change every character, because, yeah, there's some notion of a transaction is sometimes useful, right? But once I accept it, it's green. And I'm still in the same inspector, in the same class browser. I haven't lost my state. That's the crucial thing. This is not a refresh of a JavaScript page. That is not liveness. That is an excuse, okay? So if we go back, right, this guy's green too. Everything, they're all green. I changed the source code for object presenters. All the object presenters are now green. And I am still, right, I have this list with the 3s in it, and the presenter with all this stuff is exactly as I left it. And I'm on this slide, because all this is the same running Newspeak system. The slideware is running in the same thing. And I don't have to reconstruct my state, right? That's the problem with refreshing the page, right, is that if I had any interesting state in that web application, I refresh the page, and now I have to go figure out where it was. Now, think about how you do this with your typical mainstream IDE, right? Well, you get the source code, assuming that it's open source. Yeah, you download it from Git. You search through the files trying to figure out what controls the color of your object presenter. You simulate all that in your head, of course, because you can't run it. You just have to think about it and make sure that you understand, and you find this file, and then you build it. And if you're lucky, you use what Owen showed us the other day. You have a nice build system. Otherwise, it'll take you a long time to figure out how to build the monster. And you build it, and then you start it up again, and then you navigate to wherever the widget that you wanted to change was and see if you're right. And this bears an eerie resemblance to the situation with a deck of cards. And that's where many of us are, unfortunately. Of course, screenshots are easy, right? They stay dead. This is a screenshot like I had in the beginning, and of course, it didn't change its color. It's, liveness level 1. Now, we can move on to the next topic, which is literacy, or specifically literate programming. How many people are familiar with literate programming here? Okay, that's a bit better. We've had a bunch of people talking about documents, whatever. But anyway, I will explain on this, and you do not need to understand this integral, neither do I, but it is here. We're not interested in semantics. We're not even interested in its syntax. We are at the level of code review. We're talking about formatting, right? The time that people waste on that. But here, formatting is non-trivial, right? It is very hard to format this by hand in the old, to typeset it by hand, right? You have 3 sizes of characters here. You have regular characters, subscripts, superscripts, and subscripts of superscripts, and all of this has to be at the right offset, and this is pretty labor-intensive to do manually, right? And so this is the origin story of literate programming, which I love to tell. This is The Art of Computer Programming by Donald Knuth, And the story goes that when the second edition was being prepared in the 70s, the first one had been done by elves by hand the way nature intended. And this got too expensive, so the publisher started cutting corners. And Professor Knuth decided to solve this problem by writing a tool that would maintain the quality of the typesetting but actually be cost effective. And that, of course, is TeX. And then Professor Knuth decided that actually he should write a book about TeX, or actually a whole series of books about TeX and the allied tools like Metafont, which is a DSL he devised to describe the fonts. And then he decided he needed new tools for that, because some of these books are actually literally the program, TeX, the source code, with comments and narration and explanation of why and how and so forth. And if you do this, if you're writing, say you're not writing a book, but even an essay where you're describing a program, you're taking the program from some file and pasting bits of pieces out of order, of course, because you're explaining it in a different order than the source code is in. And in the end, you have no idea if what you've written includes the real program, because with all this copying and pasting and editing and whatever, who knows if it even compiles, let alone runs correctly, right? So it would be nice if there was a single source of truth. And so Donald Knuth developed this system where you had this one text that included the typesetting instructions and the narrative and all the text and the bits of source code, and it would compile that into the input for the compiler, right? So it would be the source both of the book and of the real program that he developed. And more importantly than that, he came to the conclusion that this is a good way to program, because programs are read much more often than they are written, and it is useful to have a narrative describing the program so that people can read it and understand it. And that became the motivation for literate programming. And I'll take it one further. It is, even if you have no audience, even if you don't expect to write an exposition for other people, it's good for you to write a narrative describing what you're trying to do. That's why we have design docs, right? That's a weak form of the same approach, because writing is the ultimate tool for thought, right? It basically lets us take our small, unreliable local memory and export it to a unbounded, persistent storage system. And so, really, it's really good. But I know programmers will never do it. But the point being that he built these tools. And of course, the next thing he did is wrote a book about the tools. So he had a book about the tools that were made to write a book about the tool that was made to write a book, because that's how things should be done, right? And what does this all have to do with liveness or anything else? Well, let's see. But before that, oh yeah, I forgot. I have to show you this little video. So this is I believe the 2013 Oscars, not the Best Picture, but the technical awards, right? The people who do, build cameras or whatever, right? And physically based rendering is a book about CGI and ray tracing. In fact, it is a literate programming book that they wrote. That they wrote a ray tracer that was used as a standard in a lot of places, and it became sort of a Bible for the CGI industry. The people in movies used it, and so they thought it was important enough to give them an Oscar for writing the book. And this is them at the Oscar ceremony, and hopefully the sound. I'm not sure if the sound will work, but let's see.
So, needless to say, when we started writing a book, we never expected an Academy Award would be the end result of that effort. We'd like to also thank Donald Knuth, who invented this idea of literate programming.
So, that's kind of cool. But, maybe you'll write a book and get an Oscar too. But what does it have to do with liveness? Well, let's take a more modern example. Here's the Rust book. Right? And it's interactive, right? It is a book which has snippets of code in it, and you can go and interact with it. You can find these snippets of code, and you can run them, and it gives you a result, right? That's kind of nice. So obviously, if it's a good idea to have your program described as a narrative, it's an even better idea to have your program described as a narrative where you can actually run the program and interact with it in the narrative, right? So liveness is important here. Now, this is not the most live thing. It's a very nice tool, but in fact, yes, how do you produce these? There's this tool called MDBook, which is sort of Markdown, and you go and edit some dead files, and eventually you build the book, and then you have your live book. But the process of building the book itself is still dead, right? But we've just seen that one can do better, right? We have this slide presentation where we can, interactively run things and put in widgets and do stuff. So here's an example. The tool, there's this hierarchy of tools. There's Newspeak at the bottom. There's this thing called Ampleforth, which is a live document system. And then there's Telescreen, which is just a particular document that knows how to handle slides. Because the difference between document and application disappears here. Because once you can put widgets in your document, imagine that your document doesn't have text anymore. It's just widgets. You've got a GUI builder, right? And so in this particular slide, we have another Telescreen presentation. And I can edit it, right? I'll say slide 1. And I'll make a new slide just so we have something more interesting. And so it puts out another template. And each slide itself is a document. So they're nested documents within documents. So this is slide 2. And I can press previous and go back to slide 1. And I can display the slide list. So I actually have slide 1 and 2 here. And if I go up here, I can display the slide list for the presentation I'm showing you with all the slides here. And so, yeah, we've got a presentation within a presentation. And yeah, maybe you don't do this very often, but the point is that everything should work this way because of compositionality. This is, you have to be able, it's like combinators, right? There are operators that take certain values in a space and map them to the same values, so the combinators give you these unbounded things. This is how languages work, right? They're basically expressions composed in this way. This is how algebra works, everything. This should be taught in CS 101, but it obviously isn't because you can see all the tools around us, they don't work this way. So now moving on to local first. How many of you are familiar with the notion of local first programming? Okay, well, we'll explain that too. Local first, the term local first was made popular by Martin Kleppmann and Peter van Hardenberg and a few other people. They wrote a paper in 2019, and they got traction with this, and they've done a lot of work with CRDTs and stuff to actually make it work in some things. But the basic idea, I'm going to give you my perspective because I've been talking about this for 20 years, so before it was called local first. But the basic idea is you want the best of the cloud and of traditional pre-cloud like native applications, right? So cloud has all kinds of advantages, collaboration and backup and many more things. But traditional applications have certain nice properties as well. In particular, they work when the cloud disappears on you. Right? When the network is down or slow or unreliable or insecure or what have you, or when the network is up but your cloud provider is down due to an outage or denial of service or what have you, right? So local first is really an attempt to get you things that still have the advantages of cloud but actually work locally. So another way to put this is software should live up to these two slogans, always available and always up to date. And the second is a bit controversial, but I'll go through this. Always available. The local first people tell you, you're right, it isn't available. I want it to be available on a machine even if I don't have a connection to the cloud. And that's very true. And the cloud people will tell you, oh yeah, what if your machine got crashed or stolen or you forgot it at home? Where are you now? And of course, then you can use the cloud from any machine anywhere in the world, right, as long as you have a network. And of course, both of these things should hold. You should be able to, if you have a machine or a network, that should be enough. It would be nice if you could do it without a machine and without a network, but that's Liveness level 1. Then you have to do it in here. It's kind of hard. The always up to date is different, right? So the basic idea, and this is what motivated me, was I want over-the-air updates. I never want to deal with versions of software. Now the local first people take one step and say, no, actually one of the advantages of local first is if I don't want to upgrade my software, I have my version and I can keep using my PowerPoint from 1989. The problem is they also say that you can do collaboration, and that doesn't fly because if you're doing collaboration, you need somehow, you have to be on a compatible version. And so my take on is this, we want these things to update automatically. And of course, liveness plays in here, because if you have a live level 4 system, you can do the update over the air without taking it down. So, more broadly, there is this problem. What makes all this hard is the problem of reconciliation, right? Because once you do local first, that means you can be offline and keep working. So you've changed things, and now you come back online, and there's a version that you left somewhere else, or you or your collaborators, and they have to be reconciled. They have to be put back in sync. And that requires a reconciliation. And the classic example of this that we've been doing for many years is version control, right? Like things like Git. That is asynchronous, offline, dead reconciliation, right? But it's hard because, yeah, things have diverged, and now you have merge conflicts and all these problems. On the other hand, we also have this idea of live, synchronous reconciliation, which is more or less instantaneous. If you do Google Docs or things like that, right, it's live. You can see what the other person on the other side of the world is typing and where they are, where their cursor is, and on all that stuff. And ideally, again, you want both. Maybe you can make them both work with the same underlying mechanism as the CRDT people are trying. Maybe you need separate mechanisms, but from the user's perspective, this shouldn't matter, right? This is something you want. And if you want my full take on this, since I have been talking, this is a video. You can look it up on my YouTube channel, Objects as Software Services. There's also a white paper on my website. This is from 2007, a talk I gave at Google. There are later ones, but I'm posting this because it's the earliest one that I can find, because earlier ones weren't recorded because they didn't record things in those days, you know, the Stone Age and all that. So, oops, that's not the button I wanted to press. This is the button. So now, functional programming, lambdas. Functional programming doesn't start with an L. We couldn't use that. So reactivity, for example, is a form of liveness. Oh, it says reactivity. That's an interesting word. It actually makes sense, viva. But let's fix that. And so it has its roots in functional programming. Not to say that people didn't have similar systems before functional programming. There's constraint-based stuff going back to the 70s before John Backus and his speech and all that stuff. And of course, all of this works better in the functional world, because in the imperative world, as anyone who has used React knows, things get rather messy because of their state, right? And this is a problem. But anyway, there is these things where liveness in some sense would be easier in a functional world. Now, there are probably people who know Elm much better than I do here. Okay, so shut up, don't tell. But the Elm model is a very nice example of a reactive model that in a pure functional language, right? So Elm is this lovely language basically for building web UIs is its main purpose in life. And so you have 4 data types, 2 of which you define and 2 of which the system defines, right? You've got model. You define a model of what it is your application is about. You have a change description, which is basically a type describing what changes you can make to the model. Then there's the system provides you with some sort of data type for UI descriptions, and for user input, which is really a subset of UI descriptions. It's like who clicked what and so forth. And then you have functions. You have a view function, which you write, which takes a model into a UI description. And you have an update function, which takes a model and a change description and gives you a new model. And then the system provides the GUI, or sometimes it's called the computer or whatever. Evan-Stop terminology in Elm is a little different, but basically it takes a UI description and displays it, and then it takes user input, and it spits out a change description, which sometimes even calls a message. And you can tie all these into this sort of recursive equation of lazy strings, but it's easier to look at this, right, as a diagram. You start with an initial model, you feed it through the view, you get a UI description, you feed it to the GUI, then you feed user input, it spits out a change description, it goes into the update function, which also takes the model that you had, spits out a new model, and this cycles on forever, right, in the event loop. So this is a very, very nice model, purely functional, works nice, though if you have complicated states, somewhere you're going to actually have to put it in the model and manipulate it. Nothing comes for free. But yeah, this is Elm, and Elm, yeah, it's a great way of creating live experiences, right? Like this turtle, we can turn him around, and he can go forward, and things like that. And this is Elm running inside the slide, and yeah, there's the Elm program here. But Elm itself could do more for liveness. Actually, at one point they had a time-traveling debugger, which is a fantastic thing, but they took it out for reasons. But you see here, this button, it says rebuild. Whenever you see the world build, run away. Nothing should ever be built. It should be live and change whatever. So now it doesn't take long to build because a small program like this is fine, but basically that's not the thing we really want. Now, this is Hazel. I suspect that nobody knows about Hazel, and now Hazel isn't answering. Hello, oh, there's Hazel. And how many people have heard of Hazel? Okay, that's better than I expected, but that's still a very distinct minority. So Hazel is a research project by Cyrus Omar and his associates, University of Michigan, I think, wherever Cyrus is these days. And they have this thing called Hazel, which is a functional programming language which supports liveness. And so we've got an evaluator here that's very much similar to the Newspeak evaluator we saw before, and it does liveness level 3. So I type 3. Well, I type 3. Come on. What happened, Hazel? There. And now I can type plus, and it doesn't give me an error. It gives me this nice story about what plus should do and what the types are and all this. But what's even more interesting is, right, I can now say times 6. And it's still happy, even though there's this thing here. It's got a question mark. That's a hole. So if you're familiar with the notion of type holes were invented so you could type check programs that were incomplete, which was a huge blind spot or hole in the functional programming world for a long time. And they've taken this and created also syntax holes and value holes so that you can kind of work with things. So this actually works much better than the Newspeak evaluator because it can actually keep it, working for you even though you're broken in the middle. So that's cool. And again, this is easier with a functional language because if we evaluate expressions, they're going to have side effects and things, and God help you, right? So we may not want to do this. But there's a tie to liveness and functional programming is the moral of the story. And finally, we get to llamas, of course, which, of course, is artificial intelligence. So, and of course, Midjourney did that llama. Thank you, Midjourney. So lambdas connect to AI. Everything connects to AI, of course. So one of the aspects of this is AI programs your AI writes for you need to be vetted, right? We can't trust the things, right? The more we can have mechanical tools that can guarantee correctness, the better off we are. And so the end state of this is going to be that you tell the AI in natural language what you want. And what it derives is not a program, but a formal specification. That's what you want to look at. And then you, the human, want to look at that specification and see if that is what you wanted. And you can have this dialogue with it or whatever. And then it can go and write the complicated program that lives up to that specification, and it can go try and prove it. And when it's proven it, you know that it got it right. And until then, you don't have to worry, right? So we're still a ways off from that, but we're not as far as most people think in my mind. So anyway, there's a connection there. Local first, there's a really interesting connection here. So local first is really about user agency, about individual power versus cloud, the power of the cloud, of the big providers and so forth, about balancing that. And that is very much in the humanistic tradition that live programming comes from, because all this live programming comes from people like Alan Kay, the Dyna book, if you know about that. If not, that's another talk. But basically, in the late 60s and early 70s, immensely prophetic writings and experiments that eventually led to Smalltalk and so forth. And they were all about empowering people. They were all about giving people control over the computer and so that they can educate themselves and do experiments and have it serve them in various ways. So local first is very much a fit for that. And all of this is way more important now with AI, because now we really have to balance the power against the big providers, right? So what you really want is your own AI, right? There's lots of reasons to have multiple AIs so they balance each other out, but in particular, AIs under your control, on your machine, small models, open models, etc. So that's part of the connection. Then there's this interesting connection to this model of live documents, which is the end state of the literate programming thing. So obviously there's the immediate literate programming thing, as programmers actually hate to write documentation, so literate programming never went anywhere, but maybe now the AI can write the summaries for you, or things like that. But the bigger issue is these live documents are a great way of composing multiple tools and applications and breaking down silos, right? This is actually how Smalltalk was supposed to work, right? Not individual apps that can't talk to each other, right? Now, AI is going to break down all those silos anyway, because it's smart enough to now figure out how to call APIs and get different pieces to talk to each other. And we'll evolve from these chat sessions, which are really like REPLs a lot, and into something where it basically puts things together for you and customizes the UI with different widgets and makes them talk to each other, right? So you get into this notion of a space. But we're not going to stay on spaces like this for very long, right? Because the future UIs, in my mind, are more like smart glasses or visors or contact lenses or God knows what, where you're in an augmented reality with these widgets where they do things for you. And so the documents become rooms or overlays over rooms, and if it's VR or AR. And the links between documents become portals into other rooms or spaces. And all of that, is an extension of this model of the live document to a live space. And then this is where liveness comes back, because if you're doing that, if you're creating tools on the fly to help you around you, and you become used to living in this, you want the AI to be able to control this and reprogram this. And ideally all the way down. Again, not refreshes, not just the tools, but all the way down, which means you want a live system. You want a live engine underneath this, right? So the engines that were in the list machines and in Smalltalk and Self and all those things have a person. Of course, they've inspired everything you do. Your Java engine is based on that very directly. Literally, lines of code come from there. JavaScript as well. But they're all deliberately lobotomized from what the originals could do, because the people who dictated how these things would be used did not understand live programming. But this is going to be much more important, because now we need to fix this. We can't wait for it to rebuild the system when we're navigating our augmented reality. And we can't, in particular, again, going back to the fact that we can't have it reconstruct the state that we were in, right? It has to update the system while it's running, so all the state that we had is still with us. So I think that live runtimes have a big role here. And yeah, I don't know how the time went, but that's really what I had to say. And I keep pressing the wrong button. This is just the credits for the various images and all that stuff. But I'm done, and thank you for listening.